Hello, today we're looking at the UNA-F-42, a unified telephone set with buzzer calling, model 1942. The telephone was a further development of the buzzer call telephones of the UNA family. Its predecessor was the UNA-F-31. In the Red Army field telephones were generally divided into two main categories, magneto-call telephones and buzzer call telephones. Shortly before the war, a third type also appeared, the combined magneto-buzzer telephone, which incorporated both calling systems. By the beginning of the war, buzzer call telephones made up the majority of field telephones in the service with the Red Army. The 1940 Red Army Signalman's Handbook states, the telephone set with the buzzer calling is used from the rifle company level up to and including the rifle division level for communications between higher headquarters and command posts and their subordinate units, that is, for so-called combat communications. These telephones were less demanding when it came to the quality of communication lines and could operate even on lines with the poor electrical characteristics. In addition, they could be connected to telegraph lines. The Soviet Union had a well-developed telegraph network, and using existing telegraph lines instead of laying new field cables was a common practice. UNA F-42 specifications: power supply 1.5 volts, communication range over PTF field cable 15-18 kilometers, over telegraph lines 30-40 kilometers, over overhead lines 100-200 kilometers, weight with the battery installed only 3.2 kilograms or 7 pounds. For comparison, the UNA E-31 weighs 7 kilograms or about 15.5 pounds. Here you can see the difference between them. So what exactly is a buzzer call telephone? Unlike magneto call telephones, this set has neither a bell nor a magneto generator. Instead, it uses a buzzer, a device whose main component is a transformer. When the call button is pressed, the buzzer generates a high frequency signal and sends it into the line. On the receiving telephone, the signal is heard through the handset and serves as the incoming call signal. The construction is simple. The telephone is placed in a wooden case painted green. These cases could be made of solid wood or of plywood. This particular example has side panels made of solid wood, while the top, bottom, and front panel of the telephone frame made of plywood. The lid is attached to the rear wall with two hinges and is secured by two latches. Unfortunately, the original latches have been lost, but we plan to install new ones soon. On the side of the case, there are two steel brackets for attaching a carrying strap. As usual, the original strap hasn't survived. To the right, we have the call button. Pressing it sends a call signal to the telephone on the other end of the line. A slot is cut into the front panel to allow the line wires and handset cord to exit the case. When the telephone is not in use, this opening is covered by a shutter. In the lower left corner, there is a metal plate where the serial number was originally stamped. Unfortunately, almost nothing can be written on it today. Let's open the lid. On the lid, we can see the telephone schematic diagram, testing instructions, and diagrams showing different ways of connecting the set to a communication line. One diagram is for use at an intermediate station, and the other is most likely for use at the end station. There is also a fabric handset retainer and a holder for a screwdriver. This model can be found with either a high or a low handset. This particular telephone is a high handset version. On the front panel, there are four terminals: L1, L2, Gazette, grounding, and KL, which is used for connection to a telegraph line. Notice that because this telephone can be connected in several different ways, a simplified circuit diagram is printed directly between the terminals for convenience. The capacitor and lighting arrestor are shown on this diagram. We also have a standard headset connector and adjustment screw for the buzzer. The telephone frame is secured to the case with two screws. This model is described in many books. In the 1937 Telephone Engineering, it is the very first telephone discussed in the chapter dedicated to telephone sets, which says a lot about how common it was in military service. The handset is made of plastic. It follows the standard design used on Red Army field telephones, although black versions can also be found. This example is brown, while the PTT and the receiver cap are black. There is also a slot for attaching a hook. This may indicate that the handset originally belonged to a switchboard or some other piece of communication equipment. Although these handsets may look identical on the outside, the internal wiring can differ, meaning they are not always fully interchangeable. The main differences are found in the PTT. Some versions have only 2 contacts, while others have several. This handset has 3 contacts. Because of these differences, some handsets were marked to indicate which telephone model they were intended for. The handset cord is covered with a green fabric braid. Sometimes rubber sleeves are presented at both ends of the cord to prevent it from bending sharply. This example has one of these sleeves near the plug. The plug is made of metal, and the locking screw has a special grip to make tightening and loosening it easier. As with the most Red Army field telephones, we press the PTT when speaking and release it when listening. Let's take the handset apart. The transmitter is REA MB629 type. It's a carbon microphone and it can be disassembled for servicing. Also, MB5 can be used. The MB transmitters were produced in 2 versions, a 3-volt version for older telephones and 1.5-volt version. The 1.5-volt transmitter were marked either with the number 1.5 or with a dot of black or white paint. Both versions are interchangeable. The difference is in the resistance of carbon granules inside the capsule. A 3-volt transmitter can be used with a 1.5-volt power supply, but the communication range will decrease by approximately 20%, and vice versa. 1.5-volt transmitter with a 3-volt power supply can increase the communication range. A rubber ring to hold the transmitter more securely. In the upper earpiece cup, we can find a receiver assembly consisting of 2 electromagnets and a diaphragm. When alternating current is applied to the electromagnets, they generate magnetic field that causes the diaphragm to vibrate, producing sound. As with other handsets of this type, if the microphone is broken, you can still speak into the receiver. Now let's remove the telephone frame from the case. Inside, the design is extremely simple, but also very interesting. The simplicity of the circuit was one of the main advantages of the buzzer call telephones. There are only 4 main components: the lightning arrestor, the buzzer transformer assembly, the capacitor, and the call mechanism spring assembly. The lightning arrestor consists of several insulated metal plates and serves to protect the telephone from lightning strikes on the line. The capacitor is used when the telephone is connected to a telegraph line, where both the telephone and telegraph operate simultaneously. The capacitor blocks the direct current used by the telegraph while allowing the alternating telephone signals to pass through. Ideally, the telephone should be connected through an additional filter, but a functioning capacitor is the minimum requirement for operation on the telegraph line. If the capacitor becomes shorted, the telegraph circuit will be grounded, disrupting telegraph operation. The buzzer transformer assembly combines several functions in one single unit. It serves as the source of the call signal and also transforms the speech currents. The assembly consists of transformer, a moving part with a spring, a contact spring, an adjustment screw, and an additional resistor. The operation of this device deserves a video for its own. The battery was installed here in a horizontal position. These are batteries terminals. The wiring is made of cloth insulated conductors impregnated with a paraffin wax. Inside the case there are wooden supports for the telephone frame. The gaps between them were often filled with sealing material. When we press the call button, it presses the springs of the calling mechanism. Now let's put everything back together and connect the battery. Let's test the telephone. By the way, the instructions are written in an interesting typeface. Those who speak Russian will notice that the soft sign is larger than the other letters, and letter E looks like if it is made from the same soft sign combined with the old Russian E. Perhaps it is a modified version of pre-revolutionary Russian typeface. So let's begin. Check the calling circuit by pressing the call button. The buzzing sound produced by the buzzer indicates that the buzzer is functioning properly. Make sure the call current is reaching the line. To do this, place moistened fingers on terminals L1 and L2. A tingling sensation indicates that the current is present on the line. From my own experience, I can say that it is much more than a slight tingling. It's actually a pretty energizing electric shock. Check the speech circuit. Connect terminals L1 and L2 together with a jumper wire, and when pressing the push-to-talk switch, blow into the microphone. The presence of noise in the receiver indicates that the speech circuit is functioning correctly. The telephone is fully operational. Sometimes the buzzer would stop working for some reason. In most cases, the problem could be solved with a simple adjustment. The adjustment assembly consists of two screws. The outer screw is a lock nut, while the inner screw is the actual adjustment screw. Let's deliberately misadjust it. First, we loosen the lock nut and turn the adjustment screw. Now let's try sending a call. No buzz, the call current is no longer reaching the line. To adjust the buzzer, we slowly turn the screw while periodically pressing the call button until we achieve a strong, clear buzzing sound. I'm turning the screw and you can hear the buzz changing. Once we are satisfied with the adjustment, we tighten the lock nut. Now let's connect the telephone to a 500 meters line. It's about 546 yards. According to the manual, buzzer call telephones and magneto call telephones cannot be connected directly to one another. On the other end of the line, we will connect UNA-F-E telephone, a model that combines both calling systems. Let's send the call from both telephones. When a call is sent, the buzzer sounds in our telephone, and the signal can also be heard in the handset of the receiving telephone. I'll now move the second telephone into another room. This will give you a better understanding of what a duty signalman would hear when receiving a call. My comrade is at the other telephone right now. I'll send him a call signal and then he will send one back to us. A 500-meter line is too short to demonstrate it properly, but one of the disadvantages of the buzzer calling system was that the signal became weaker on very long lines. Because of this, regulations required the duty operator to keep the handset close to his ear all the time. Now let's test the speech quality. And now let's check how our MB629 transmitter performs. To do that, I moved my microphone to the other telephone.
Hello, connection quality check. Connection quality check.
If you have watched this far, let me know in the comments what you think of the sound quality. I am also taking requests for songs you would like to hear transmitted through these telephones in future episodes. Today we have been looking at the UNA-F-42 unified telephone set with buzzer calling, model 1942. This telephone was developed based on the lessons learned during the early stages of war. It became the next step in the evolution of buzzer call branch of the UNA family. It is simple, reliable, lightweight, and easy to operate. Thank you for watching and see you next time.